Today we're going to talk about writing equations of lines. Previously, you were given equations of lines and then you had to create a graph of them. Now what I'm asking you to do is, given a graph or some information, find the actual equation or what the relationship between x and y is. So we'll run through some examples. Go through this at your own pace. If you feel like you're getting the hang of it, then you can just press pause for every sample one, work it on your own, and then check at the end of each problem. That's fine. Just be ready next class to discuss the methods to write equations. Okay, so if you remember, this is slope-intercept form. Slope-intercept form is very appropriately named slope-intercept form because we can very easily tell what is the slope and what is the y-intercept. So if you know those two pieces of information about an equation, the slope and the y-intercept, then you can very easily and very quickly write that equation. So let's take a look at this one. On this one, I'm giving you the slope, or you might do a little bit of work, but you can figure it out pretty easily what the slope is, and you can very clearly see what the y-intercept. So let's start with slope. From this point to this point, we are rising up 1 unit, and we're running to the right 3 units. So the slope of this line is 1/3, or 1/3. The y-intercept, this line is crossing the y-intercept at the value 2. So if you know that y equals mx plus b, we can actually erase m and replace it with 1/3, and I can erase b and replace it with 2. This is the equation of the line in the graph. Y equals 1/3 x plus 2. A way you can check yourself is you can take the coordinates of another point on the line. For example, this line, or this point, has the coordinates 3, 3. If I plug these into the equation, then it should satisfy the equation. So let's try checking it. Does the y value 3 equal 1/3 times the x value 3 plus 2? Well, let's see. 1/3 of 3 is 1. 1 plus 2 does equal 3, so yes, this value, or this equation works. Okay, let's try it again. Feel free to press pause and work on your own, or follow along with me. Looking at this equation, or this graph, ask yourself, do I know what the slope is, and do I know what the y-intercept is? Okay, probably pretty easily we can see the y-intercept. It's 3. Slope is going to take a little more work, but we can totally do it. From this point down to this point here, we are moving down 1, 2, 3 units, and we're running to the right 6 units. So the slope of this line is -3/6, but we want to simplify that. -3/6 is really -1/2. Okay, so now just plug it in to slope-intercept form. I'm going to replace m with the slope 1/2, or -1/2, times x plus 3. Let's try it again. Write the equation of this line in slope-intercept form. So again, ask yourself what the slope is, ask yourself what the y-intercept is. This y-intercept is really easy to tell. It's crossing the y-axis at -1, so the y-intercept is -1. The slope of this line, how about from this point, the y-intercept to this point? Looks like I'm rising up 1, and I'm running to the right 1. So the slope is +1/1, or just 1. So putting this into slope-intercept form, y equals mx plus b, I'm going to replace m with a 1 times x, and then the y-intercept, -1, like that. Some people might ask me if that 1 in front of the x is necessary. No. We can always assume whenever we're multiplying by 1. So if you wrote your equation like this, y equals x minus 1, both of those equations are equally correct. Okay, here's one. I don't have the graph for you. You're more than welcome to graph it, but we can put this into an equation in slope-intercept form really easily because we're told what the slope is and we're told what the y-intercept is. So if y equals slope times x plus the y-intercept, erase that for a second. Slope times x plus the y-intercept. I'm going to go through and I can replace m with -4, and I can replace b with +6. And there you go. There's your equation in slope-intercept form. Let's try again. Write the equation of the line with slope 1/2 and y-intercept of -3. So if y equals mx plus b, then I can go through and replace m with 1/2 and replace b with -3. Right now my equation is y equals 1/2 x plus -3. Well, I don't have to write it like that. I could also write it y equals 1/2 x minus 3. Either of these ways are equally correct. Okay, one more. Write the equation of a line that is parallel to this line and has a y-intercept of 7.4. So think back a few lessons. Parallel lines have the same slope. Or equal slope. So the slope of the line that we're looking for will be the same slope of this line. And since this is already written in slope-intercept form, I can very easily tell that the slope of my new line is also 2. So slope is 2, y-intercept is 7.4, so I'll just plug this right in. Y equals 2 times x plus 7.4. And then you're done. That's writing the equation in slope-intercept form. Okay, this one requires a little more work. This is when we don't know the actual y-intercept. Not as straightforward as the ones where we knew the slope and the y-intercept, but we can easily do this. In order to do this, we are going to use the slope-intercept form. If you'll wait for a second for my computer to load. I'm going to pause this for one moment. Okay, and we're back. Sorry about that. Okay, so again, we don't know the y-intercept. So what we're going to do is use slope-intercept form to find that y-intercept. And here's how we're going to do it. If we have y equals mx plus b, we're going to plug in the slope and the coordinates of one of the points on the line. So the y coordinate of the point on the line will be 4. I'll replace y with 4 equals, okay, my slope was 2, so I'll replace m with 2. My x coordinate was 1, So I'll replace x with 1. And then I don't know y-intercept. Remember, that's what I was looking for. So I'm going to leave it as b. And let's simplify. 4 equals 2 plus b. I'm now going to solve for b, so I'll subtract 2 from both sides. So 2 equals b. This is your y-intercept. I can now plug this y-intercept back into slope-intercept form. So my equation is y equals the slope, which was 2 times x, plus the y-intercept, which was 2. And there you go. Remember, your final equation needs to have the variables x and y in it. This whole process here is just what we're using to find the y-intercept. Your final equation must have x and y. All right, let's try it again. Write the equation of the line that has a slope of 4/5, and it passes through the point 10, negative 4. So again, the point we're given is not the y-intercept. We have to find it. So using y equals mx plus b, I'm going to find the y-intercept. I'll replace y with negative 4. I'll replace m with 4/5. I'll replace x with 10. And then I leave b as a variable because that's the variable I want to look for. So negative 4 equals, well, 4/5 of 10. 5 goes into 10 2 times. So 4/5 of 10 is 8. And then plus b. I still want to solve for b, so I'll subtract 8 from both sides. Negative 12 equals b. Remember, this is now my y-intercept. I'm going to use that new y-intercept and the slope 4/5 to write the equation. Y equals 4/5 x plus negative 12, or you could say minus 12. All right, this is our last example. Why don't you press pause? Work it on your own, try and find the equation, and then when you're ready to check your work, press play. We have y equals mx plus b. I'm going to plug in negative 5 for y. I'm going to plug in negative 1/6 for the slope and negative 12 for x. Leave b alone. So negative 5 equals negative 1/6 times negative 12 is positive 2 plus b, okay? Solve for b, so we'll subtract 2, and b is negative 7. So use this now to write the equation. The equation would be y equals negative 1/6 times x minus 7. And there you go. All right, so next class you have a quiz just on graphing. It won't be on this procedure of writing equations, but we will go over it in class. And come ready to work.